Okay, so here's what we want to start with. Again, you can see that I am just recording it because I can record it for the next class, which is tomorrow, because they don't have the pleasure of having me live in person. So here is a formula that you need to know. This is not given. Remember, the only formulas that you have are projection formulas. But don't stress, because look at this. It looks really similar to dot product. Remember, dot product was U. Should I write that out maybe? If I were to do dot product, length of U, length of V, cos of the angle between them, but in this case, it's length of U, length of V, sine of the angle between them. And then you'll notice there's one additional term. It's that n term here. N is a unit vector that is perpendicular to the plane. In that visual that we just saw, what was perpendicular to the plane was that C, right? It's the cross product. So we're going to use this formula to always find the cross product of something. So if I have vector U here, and I'll call this vector V, remember this is the angle between them, same as before, nothing's changing. That, supposedly a straight line, is my cross product. So I'll maybe do it in blue just so you can see the difference. This is U cross V. That's what gives us that area component. And this is our N. Right? Technically, that's my perpendicular force. And that syntax shouldn't be a hat over top. It's an N with like a little chapeau. I don't know what it's called. Right-handed system, meaning that the angle between N and U is 90 degrees, as well as the angle between N and V, right? Because they're in the same plane. So you have to imagine that you're kind of, if you were looking at it from behind, like that's a 90, and that's a 90, if that's U and V, and U cross V. It was a little easier to see in the visual that we saw, but remember those angles are 90 between the two vectors at all times, perpendicular to the plane. You'll notice that's the first time we've probably used this nice fancy word, perpendicular to the plane. And in this case, this is that plane, right? It's the two bottom vectors that create the bottom of the box, the plane that we're talking about.
So on the purple one you drew, the cross product is perpendicular to the line you didn't draw, right?
So here, this,
like, are those
the
right
green
angles?
ones here are the same vectors here.
But is that a right angle for?
Yeah, so here this is a right angle, and that's also a right angle. It's just hard to draw because it's right on top of each other.
Wait, can you?
Mm-hmm.
Like literally what you
So,
drew.
and look here as well. So if I look at this picture, this is my U, that's my V, right? Those A and B vectors. And this is the cross product. Notice how it's a 90 here and a 90 there.
Yeah. Okay.
So it's the same thing in this photo. So that's my U and V here. So my cross product, my two vectors here, U and V, or my U and V with 90 degrees.
I'm just wondering, because I know that we sort of, it's more specific now,
Mm-hmm.
but is it appropriate to put a, like a X as a multiplication symbol in this?
Yes, because that is cross product. So it has to be X. Exactly. X being cross product, not multiplication. So that's why it's now, woohoo, time for your grade 7, no, grade 3 multiplication skills with X in the middle. Okay, wonderful. Again, you do need to know the magnitude of the dot product. So if I want the length of it, a formula that is not given. So essentially, any formula that you see in this unit besides projections, you are responsible for. And here's our first example. If I give two vectors, and I'll have to draw them out because I did not include the diagram, vectors U and V. We'll say that V has a length of 20, and U, lovely, has a length of 30, and they are 40 degrees between each other. We're going to compare the three different types of calculations we have seen before. U cross V versus V cross U. This is important, and you'll kind of see here. So just looking for the cross product. Remember, I'm looking for the magnitude of U, the magnitude of V, times the sine of the angle, with my hat, with a chapeau, with a hat. Magnitude of u, not a big deal. 30 times 20 times the sine of 40 degrees. So that's my cross product. Notice I'm just including the n because that tells me that that is that perpendicular force. It's that unit vector perpendicular to my plane. Okay. And I'll say where n is the unit vector perpendicular to and out of the page. I just want to get us into this habit right now because this is important. If my two vectors u and v, that big yellow screen, I can kind of split this, which is nice.
Is it the one coming directly towards you in this case?
Exactly. So here, I don't know, I can't make that smaller. That was helpful. Trying to keep everything up so you can see everything, but you can see that's not happening. If I have my vectors u and v, so u and v, imagine they're in the plane. So they're in a piece of paper. This is u and v. The cross product is always perpendicular to that page. So this is the plane. U cross v goes out of the plane. The opposite, if I have v cross u, will be the exact same magnitude, but it's going to be negative in value. Denoting that it will go in to the page, down instead of up, but still perpendicular. Wonderful. Okay, so that's kind of the easiest you'll see for cross product because we're going to go into doing some actual cross products. One more example though with area. And out of the page. Out of page. Out of the page, maybe? The page. Notice a second way. It's not going to ask for the cross product like it did here. It'll say determine the area. It still means cross product. So you think. And it's going to be defined by the vectors below. You actually need a diagram, so this would have to be included. I'm going to say this is vector u of a length of 5, vector v, length of 7, and this will be 50 degrees between them. Okay. Now, looking at the area, this is how it's working. So everything in green would be what is given in a question. That's the area. I can kind of see that, woohoo, I can divide that into a triangle. This is the way, this is just the reasoning behind why our formula works. So when I'm finding the area, I'm finding the cross product. The magnitude of u times the magnitude of v multiplied by the sine of 50, because remember this is a magnitude question. Magnitude of u, magnitude of v, sine of the angle in between. Five times 7 times the sine of 50. Don't know what the units are, they're just squared. So notice we've used those two formulas. The first one highlighted at the top was to find a cross product with a normal vector. This is to find the area, which is the magnitude. Same idea, but magnitude. Okay, here's where it gets fun. This is the best part. This is cross product in terms of components. So if you don't have the angle between, okay, so here, think no angle. And a little bit differently than when we had two components, you're not going to find the angle between a three-dimensional component and another three-dimensional component very easily. Which means we have to learn how to do it with components. They're written out the same way. A is A1, 2, 3. B is B1, 2, 3. When I do the cross product, we have to write each vector out twice. So here's what you would do. You go, we'll do A's, actually, let's do red. This is important. Red seems like an important color. A1, A2, A3. I wrote it out once. I'm going to write it out again. Okay. A1, A2, A3. I'm going to do the exact same thing with the B's. Should I keep it red? Yeah. B1, B2, B3. B1, B2, B3. This is so important, and you need to write it out every time. Not with the actual B's, but you're going to do it with numbers when we get to vectors with numbers. The reason we do this is that it kind of covers all of our bases for components, making sure that we're multiplying all the A's by the appropriate B's. So when I do this to find a cross product, you always leave out the ends. Okay. I'm not a big fan of crossing them out, scribbling them out. It's up to you though. Okay, so I'm not using these ever. I will erase those at the end. You don't have to draw them in now. It's A1 times B3. So notice I'm making crosses. A1 times B3, subtract B2 minus A3. Let's go through this again. Go to the next pair. A3 times B1. Subtract B3 times A1. A1 times B2. Subtract B1 times A2. Okay. Let's try it out. The only way to do this is practice. And like I said, I don't like having the scribbles there. I think that looks prettier, but sometimes students like to just scribble them out and scratch them out so they don't have to even think about them. Right? Your prerogative. So find A cross B given three components. Please write out your 7, 1, negative 2, 7, 1, negative 2. We write out the bottom components. I'll switch colors for no reason. 4, 3, 6, and 4, 3, 6. I draw my crosses in right away, and I'm just going to give them a little more space. And then I go back and I do the work. So for me, that's like the perfect way to do it. Draw in my 3 X's, 3 components, 3 X's. And we're going to write our cross product out. So if I have A cross B, my vector components, it's 1 times 6 minus 3 times negative 2. Comma, that's my first component. I move on to the next stage. I'm going to just make that a little smaller so I can fit all my whole work here. So that's my first component. I go on to the second one. Negative 2 times 4, subtract 6 times 7. Negative 2 times 4, subtract 6 times 7. Move on to the third component. 7 times 3, subtract 4 times 1. And I get the cross product, which is also a vector. 12, negative 50, 17. So that's that C that's perpendicular to the plane. All right, how do we feel? Scale of 1 to 5. 5, fantastic. 1 is utterly horrible. We love crosses. We don't like crosses. Love crosses. You must vote. I will wait for the vote. Come on. Calvin, just a little vote. I feel like that was a little harsh. It takes practice, okay? So we're going to try another one. Confirm that A cross B is perpendicular to both A and B. How do I know if a vector is perpendicular? Think back to a previous lesson. 90 degrees. Okay, so if it's 90 degrees, what's equaling to 0? The dot product of those two vectors. Okay, so something is perpendicular when it has a dot product of 0. So if it wants to know that it's perpendicular to both A and B, I need to do 2 dot products with the vector A cross B. So here's what I would do. The first one, 12, negative 50, 17. I'm going to dot that with A, and A was 7, 1, negative 2. And I'm going to do the same thing over here, 12, negative 50, 17, dot B, which was 4, 3, 6. For notation, you would write that that's A cross X dot B for that, but we'll get into that specific notation in a second. Okay. So this becomes 84 minus 50 minus 34, which in fact is 0. On this side, 12 times 4 is 48 minus 150 plus, that should be 102. Magic numbers. So I can say, therefore, A cross B is indeed perpendicular to vectors A and B, which is the rule. It will always be. If you've done a cross product, it has to be perpendicular. That's how this works. We're looking at area vectors. Yeah, we for sure could. If it were a test question, I would like that. So I say, therefore, A cross B is perpendicular to A, and it's perpendicular to vector B. A very tiny therefore statement. Okay. Next one, determine the area of the parallelogram defined by these vectors. I'd like you to take a minute and try those vectors out. I'm going to freeze the screen so you can't see it. You're going to be doing the exact same thing you've done here with cross product. Right? Don't go on to B yet, just try to do A. So cross product between 3 vectors. And remember, I'm looking at the magnitude of that cross product. So first find the cross product. Yep, you cross V, exactly. Yeah. Your final solution should be 36.7. Therefore, the area just give me a second, is 36.7 square units. Okay.
That's not this for 1494.
Oh no?
Yeah, my calculator says
Try it again.
38.65.
Love it. 38.65. Thank you, Graham. 38.65.
I found the dot product first.
Perfect. So you have 2 steps. I've done it all in one giant mess. If you'd like to do it too, fine. If I'm talking about area, I'm talking about cross product. So I write my 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. And I'm doing the cross product here. So I've just written this cross that. So I know what I'm doing. Remember, I go 5 times 7 minus 2 times 2. Okay, that's going to give me that 31. Going through 2 times 3, 5 times 7, or sorry, 7 times 4. Second one, third one I'm writing 4 times 2 minus 3 times 5 gives me this. Again, area is a magnitude. So I find the magnitude of this vector here, of the cross product vector, to give me 38.6 square units. So you should have taken probably 3/4 of your page or so up. If you have tiny writing, maybe half a page. If you have writing like me, almost a full page.
I kind of just skip most of the parts where I wrote down all the multiplication.
That's fine, and if you do, not a problem. It's just if you make a mistake, I can't give you part marks. So think of it like a part mark catch. Okay? But you do not need to show it. Okay? What you could also do, you could say, like, simplify this, right? Like, whatever the number is, so you have -4 here and things like that. So you don't necessarily need to have it the multiplication right now. Okay, last one. Determine the angle between vectors u and v. So if I'm looking at b, remember the angle, or the magnitude of my cross product, it should be a u cross v, is equal to the length of u, length of v, times the sine of the angle. Yeah, try and find the angle. Okay. So first I'll just rearrange for sine theta. U cross v all over u, length of v. I know my u cross v is, I'll keep it as 1494. And I have my magnitudes there. You can do the magnitudes on the side. It doesn't matter how you do them. I'll, just for kind of speed's sake here, write down our magnitude to be √45 and the square root of 62. So here for the length of u, if you're looking at doing that on the side, I can for you. So remember, u is 452. So to find that length of u, remember, you're just square rooting the components. And that's it. So the angle between the two of them is 47. This is a really good test question. Hint, hint, nudge, nudge, cough, cough. I would love to scroll up. How does that? Yeah? Well, next one. You have 2 more questions. But they're small, I think. Do you not? Perfect. Okay, we're done. Safe and neat. Okay, yeah, no problem. Just for my notes from last year, I had extras. So that's it for that then. What you want to do is move on to your homework section. Your homework is on